what we learned last week is how to prove basic inequalities. So if I had this particular relationship, which will be our starting point, x minus y all squared being greater than or equal to 0. We know if we expand this, we get x squared take by 2xy plus y squared, and therefore you end up with some sort of relationship of x squared and y squared with 2xy. So x squared plus y squared is bigger than or equal to 2xy. The 2 is a big giveaway. So if you ever see the number 2, you know it's usually forming this this formula. So from that relationship, we said, okay, we can actually say if x squared was a and y squared was 1 on a, then what would happen? I would end up with this bit being a, this bit being 1 on a, x would be the square root of a, y would be the square root of 1 on a. These would cancel out, and you pretty much end up with the result that's required. So a plus 1 on a is greater than or equal to 2. Does that make sense? Anyone have any questions about that? Okay, the next one says deduce that for a, b, and c being an element in the real field, that a plus b multiplied by 1 on a plus 1 on b is greater than or equal to b. So greater than or equal to 4. So we're trying to prove a plus b multiplied by 1 on a plus 1 on b is greater than or equal to 4. Okay. Anyone have any ideas of what they would have done? We are required to prove this. Required to prove. What would you guys do with a question like this? If that's the only result so far, you know. Ben, tell me. You've got this in you've just proven this. You've proven A. Now you've got B. Required to prove this. What would you do?
Well,
yeah. Because you know what I would do if I saw a question like this, and I'm like, I'm stuck like you are now. I'll just be like, well, I don't know. Let me just
nothing else to do.
Yeah, expand it and see what's happening.
Okay.
So I'll say, okay, I know the left-hand side is what? A times 1 on A, which is 1. This is A on B. This is B on A. And this is also 1. So now I know I've got, A on B plus B on A plus 2. Something like that. Right? Then I'm like, but I kind of see what's happening here. This actually is this. Can you see how that is that?
Oh, yeah.
Because isn't this over 1?
Yeah.
So can't you conclude that A over B plus B over A is also greater than or equal to 2?
And plus 2 means that.
And then plus 2 is 4. So what you guys got to keep remembering is, like I said, the first bit here is super important, right? And then pretty much you can get a lot of results from just this. It's up to you. So if I said let x squared equal to A on B, let y squared equal to B on A, you'll end up with this result. Or just from this result itself, you can conclude, because that's 1, 1, and 1, if I let this be B and B, you'll still end up with 2. Work the same way. Because 1 is just a number, just like B is, as long as these numbers are the same. And then that's greater than or equal to 2 plus 2, which is, which is obviously the right-hand side. Therefore, left-hand side is bigger than or equal to right-hand side. If you wanted to do that, you could have also started with the left-hand side. I mean, you could have started with, you could have done the whole thing, I guess. Yeah, you could have done the whole thing. And then you could have brought the 2 over, and then you would have proved this identity. And if you didn't want to, if you actually wanted to start from this and get it all the way to here, you could have done that as well. You would have started with this as your first line, added 2 to both sides, and then can you see that plus 2 is right there? Then you would have had to realize 2 is 1 plus 1, and then rewrite everything backwards. So that's fine as well. But why would you do that? That's perfect. C, hence, oh, sorry, and A plus B plus C times this is greater than or equal to 9. Okay, so before we look at that one, what we want to look at, if I'm not wrong, oh no, should be fine, actually. Should be fine. Yep. All right. Who can tell me what will eventually happen here, or what the numbers will be to get me 9? Because if you can see what the numbers will be to get me 9, that means you understand what's going to happen when you expand. What will these numbers be? Think of it the same as what we just did. So what's going to happen? Hey, anyone have any ideas? Without me expanding? No?
3.
3? Where'd you get 3 from? Because 3 is right.
I just guessed and I put it in my calculator and then.
Wait, what do you mean? Because you would, okay, hold on. So you see how here we expanded? Here we expanded, and look what happened. And we got 4 by knowing that these will eventually become 1. This becomes 1, so that becomes 2, and then the remaining component is also 2. So I get 4 by that procedure, I guess. So with here, you're going to get 3 by doing this times this, which is 1, this times this, which is 1, this times this, which is 1. So you're going to get 3 plus, then isn't this the same case above going to occur again? So I'm just going to get 2 plus 2 plus 2. Where that's 6 plus 3, which is 9. Now I'll expand to show you. A times 1 on A, 1. A on B, A on C, B on A, plus 1, plus B on C, plus C on A, plus C on B, plus 1, 1 plus 1 plus 1 equals 3. A on B, B on A, plus 2. A on C, C on A, plus 2. C on B, and B on C, plus 2. Do we understand that? Obviously, which is greater than or equal to, greater than or equal to, whatever. That's easy. Do you guys get that? Because I can't, like, I mean, there's no way that's going to get any easier than what I've just shown you. Is anyone actually stuck how that becomes 2? Anyone confused and want me to show that again? No? We're okay with that? Okay, any questions? All right. That's that one. And then hence, show that. So what we've done? We've done this is bigger than this. 4. This is also bigger than 9. Hence show that 9 on this is less than this is less than this. All right. Okay, let's see how we're going to do this one. So we know this condition and we understand this condition. So we can see 9 on, we know that 9 on A plus B plus C, 9 on A plus B plus C, right there, is the same as 1 on A plus 1 on B plus 1 on C being greater than or equal to 9 on A plus B plus C. Or in other words, this number is smaller than this number. So 9 on A plus B plus C is smaller than 1 on A plus 1 on B plus 1 on C. So I think we can say we got this and this out. All we need is this component in the middle, which we don't have, and somehow that has to be in between these two. So now give me a second. I guess the first thing I think about when I see this is to go ahead and try to just do it normally, which would be A plus B. Let me just see what this is as a common denominator. So A plus B, A plus C, and B plus C. You would get 2, and then A plus B, A plus C plus 2. B plus C, A plus B. Is this overkill? I think so, because it's going to become A squared, and then AC, and then AB, and then BC, and then BA, B squared, AC, 2AC, plus 2AC is 4AC. Oh. It might work out. All right, from this one, it might work out. I get 4 on A plus B, 4 on A plus B, being less than or equal to 1 on A plus 1 on B. 4 on A plus B is less than or equal to 1 on A plus 1 on B. That means 4 on A plus C is less than or equal to 1 on A plus 1 on C. And then 4 on B plus C is less than or equal to 1 on B plus 1 on C. You guys are with me with my logic there now? So I tried to use this. I didn't see it helping me much. So I was like, all right, let's go back and start from the top. And what if I can have this logic? 4 on A plus B, because I can see A plus B, right? So I started thinking of it like that. And then you guys remember from last week, we said we can just keep repeating them for the different letters. Doesn't really make a difference. They're all arbitrary. So all makes sense. This step here. Then I'm going to, because these are added, so I'm going to add these up. So I'm going to get 4, right, let's go here. I'm going to get 4 on A plus B plus 4 on A plus C plus 4 on B plus C is less than or equal to 1 on A plus 1 on B plus 1 on A plus 1 on C plus 1 on B plus 1 on C. Does anyone feel like they know what I'm going to do next? Or what they see? Or how I'm going to get this 2 out from this right-hand side? Who is overwhelmed at this stage? Who's going, holy crap?
Me.
So you're not following at all?
I got like the top part and then kind of just lost me now.
But you don't get how I've just added them? Add, add, add. Why did I add? Because this says add, add, add.
Okay.
Can you see my denominators are all the same?
Yeah.
And then can you see my right hand side? I've got this extra bits that I don't really have here. But what do you see? What do you see happen if you read this out yourself? 1 on A plus 1 on B plus 1 on A plus 1. What starts to what's
You get 2 on A.
yes, that's it. You get 2 lots of each one of these. So then when you divide it by 2, what's going to happen? Aren't you going to get 2 on A plus B plus 2 on A plus C plus 2 on B plus C is less than or equal to 1 on A, and do you get that?
Yeah.
And then you're pretty much done, aren't you? If this number is smaller than this number, but this number is smaller than this number, therefore this number is smaller than this number, which is okay. I think it's just a matter of putting it all together. Therefore, I'll just write it like that for a second so we can all see. A is less than or equal to B, but C is less than or equal to B. Therefore, A is smaller than or equal to C, which is smaller than or equal to B. Do we get that? A less than B, but C is less than B, therefore A must be less than C, which is less than B. All right. Any questions? And state the conditions under which equality holds. Equality. Equality, so such that this equals to this equals to this. For equality to hold. For the equality to hold. ABC. The top will be BC plus AB. Oh. Is there a fast way? Does it got the solutions to that one? No. Don't know which HSC paper or anything like that. It's not from the HSC. State under which can. For some reason, I feel like the only way you're going to prove the equality case is actually making it equal. And that's just going to be the annoying part that I didn't want to do. So you're going to make it all equal to each other and eventually solve where A equals something something. I guess I'll do it. We can't skip it. So actually, just need another page. Before I start that, actually, back to this. Anyone have any questions about this? Do you see how I use both answers? It's kind of there, telling you to do it. So, and then the repetition. The 1 on A and 1 on A becomes 2 on A, 2 on B, 2 on C. Divide your 2's on the left-hand side, and that just becomes 2, 2, and 2. That's what we could do. All right. Let's get this last bit out. State the conditions. I feel like that's the only way. I can't think of anything else. For equality to hold. For it to be equal. Yeah. Oh, that's annoying. 9 on A plus B plus C. 2 on B plus C plus 2 on A plus C plus 2 on A plus B. That must equal to the same as 1 on A plus 1 on B plus 1 on C. Now let me see. Isn't it easier for me to make these two equal to each other? But then you'll get BC plus AB plus AC. That becomes product. That's sum of roots 1 at a time. That's 2 at a time. That's product of roots. Yes, which is fine. Oh yeah, perfect. Good question. All right. So you got 3 things for equality to hold true. I'm going to use these two just because I could forecast a little bit faster and see what's happening. This one here is 9 on A plus B plus C equals this one here. If you remember this from again your polynomials, this becomes ABC, and then the top becomes BC plus AC plus AB. So what do we got? We've got sum of roots multiplied by sum of roots 2 at a time over product of roots. So BC plus ACC is product sum of, so your sum of roots 2 at a time. 9, and the sum of roots 1 at a time. Let's give it to your product of roots. Can I get a relationship? Can I get this out? State the conditions under which equality holds. Equality would only hold if b times c plus a times c plus a times b is equal to 9, and the sum of roots and a plus b plus c is equal to abc. A plus b plus c equals to abc. Equality holds. Am I finished with that? A plus b plus c equals to abc, and bc plus ac plus ab is equal to 9 for equality. Let me confirm. B plus c, 2 on b plus c, which is abc minus a. Yes. 2a plus 2c times a plus b. I'm just double checking it all. 2ab plus 2ac plus 2bc. AB plus AC, BC. Yeah, perfect. Okay, not wrong. So for equality to hold true, we need to have that A plus B plus C would equal to ABC, and that BC plus AC plus AB equal to 9. So this equals to this. As long as these conditions are met, this will all be equal to each other. You could have done this, like I said, to this. It would have been a little bit messier. You would have still had to end up with this particular result. All right. A little bit different to what you're used to, I know, but that's how these work. So let's try another one. Let's try this. Suppose A, B, and C are greater than 0. Prove a squared plus b squared is greater than or equal to 2ab. Again, I'm sure we know what to do there. You start off with a minus b squared is greater than or equal to 0. And then expand. And therefore you prove a squared plus b squared is greater than or equal to 2ab. Right? A squared plus b squared greater than or equal to 2 times a times b. Hence prove this. Does anyone remember how we're going to find all three terms? What's the thing I'll do next? Once I know this relationship, how am I going to start introducing C? Well, I introduce C by finding a very similar relationship to this, which would be a squared plus c squared is greater than or equal to 2ac, and b squared plus c squared is greater than or equal to 2bc. Therefore, add them all up, so a squared plus b squared plus a squared plus c squared plus 8b squared plus c squared is greater than or equal to 2ab, 2ac, 2bc. 2ab, 2ac, and 2bc. Get rid of your 2's, get rid of the 2, therefore 2a squared. Therefore, a squared plus b squared plus c squared. So you can see the good news is with these questions, they are pretty repetitive. The way to think about them is pretty repetitive. I'll stop there. Anyone have any questions? Okay, given that a cubed plus b cubed plus c cubed minus 3abc is the same as a plus b multiplied by a squared plus b squared plus c squared greater than or equal to ab plus b. Okay, cool. Minus ab, yep. Then show this occurs. All right, I think I can see it personally. Just so you guys can see some stuff as well. I hope you start to learn to look at these. It really helps for your extension, or harder advanced extension work as well. So you see that is right there. And that was AB, BC, AC. So that means that is AB, BC, AC, which means you can tell it's just going to cancel out. Right? You can clearly see that it'll just cancel out. But anyways, let's show this. So once you see this is this, we're going to start with that. So we're going to start with B. So once you think you know where the link is, I'm going to start with that. I'm going to start with this. And actually, I'll just start with Anuk. You're going to have this line right here, a squared plus b squared plus c squared. We're trying to literally get this line out because we know that line is this line, which is what we need. So you're here right now. What would be your next step? What do you think would be your next step? Any clue, Anuk? Look at that. Look at what you've got.
That equals a squared plus b squared plus c squared, does it? No.
This bit here is equal to a squared plus b squared? Well, that's what you've written.
Okay.
Remember, you're trying to get this. Because we're trying to essentially prove this, which you know is this. Right?
Yeah, I'm not sure.
But do you get firstly what we're trying to show? Do you understand how the mechanism's working? So we're trying to show this, but it's saying to show this, we know this is equal to this, right? So
yeah.
This thing is equal to this thing, but then what we also know is that this thing is actually part B.
Yeah.
So I'm trying to show you guys how to read all this. All right. Not sure on how to get from this line. Okay. Anybody else? Let's try Ben. Ben, any ideas of how to go from here? This step.
You just minus everything over, right?
Yes. Minus everything over. Let's see. Sometimes it's just the basics. There it is. Then you're saying that will be greater than or equal to 0. Now you've got this long piece. What are you going to do next, Ben? Come on, think about it. Now I want this. Be creative. You're here. You got this line. Look, you've got all of that. Now you need this. What are you going to say to me?
Would you group it or something like that?
Group it.
Or no?
Not group it. Because you've got this. You need this. So my next line needs
Square
to
root
have,
and everything. I don't know.
no, my next line literally is got to say this, just so you can see it one more time. I'll give you one more chance. My next line is literally going to be all of this.
Okay.
So what would you say to do in the next line?
Times it by a plus b plus c.
Yes, exactly. You got to times it by 8, because if you need something, you guys got to start learning. If I need it, then you get it out. You just write it out. So a plus b plus c multiplied by a squared plus b squared plus c squared minus ab minus bc minus ac greater than or equal to 0. Because 0 times anything is still 0, right? But what do you know now about this left-hand side? What is the left-hand side equal to? A cubed plus b cubed plus c cubed minus 3abc. I'm sure we can all see I am finished. A cubed plus b cubed plus c cubed is greater than or equal to 3abc. You guys are just not used to exam questions, and that's why you're struggling with this. It's not that the concept's hard. It's that you're not sure when this is, it's giving you something, how to use it. Because in year 11, most of the work has been, like, let's say, calculus. Y equals x squared, here, just do it. Whereas when you get show questions, where you've got to be creative, you're not used to that just yet. But hopefully, Ben, what do you reckon? Doesn't that whole question just make sense all of a sudden? From what we had in B and how I interpreted
It does,
that?
but I'm always like second guessing, like, oh, is that right? Like,
How many times have I told you to go with your gut instincts? The first thing you usually would think of is correct.
what was that?
The first thing you think of is
Yeah.
correct. Go for it.
All right.
So yeah, subtracted, multiplied, and then that becomes this expression, and then just plus this over. You're done. Anouk, what do you reckon? All good?
Yeah, it was really simple. I don't know. Maybe I just had a brain fart.
No, it's because you think that there has to be a right answer, but there isn't. There isn't a right answer. It's just being about creative sometimes, and you'll be surprised. Your brain will get it out. You just got to allow it.
I'm still sort of confused about the third line. So if you want the a plus b plus c, you just add it in.
No, we didn't just add it in. We multiplied it in. But yes.
Okay.
Isn't that well? Okay, hold on. If I'm here, because it's equal to 0, if it was equal to 1, then if I multiply both sides by a plus b plus c, what's going to happen to the right-hand side?
Just do the same thing.
Yeah, I'm going to still have an a plus b plus c. But because it's 0,
Okay, I
it doesn't
see.
really do anything.
So we can only do that if it was 0.
No, you see, now you're saying, oh, I only do that when it's 0. No, incorrect. You do that at any stage of your life. Whenever you want to, you can do that. It's just that in this case, it worked very nicely because it's 0. But am I allowed to go and multiply both sides by 2? Of course.
Yeah.
We've done that.
Oh.
Yes, of course we can. We've done that in completing the square. You know, we've halved something, then we squared and added. Like, we're allowed to. We're allowed to do whatever you want at any stage. We've added 1 and subtracted 1 before.
Yeah.
You're allowed to do whatever you want. You're allowed to rationalize as long as the math makes sense.
Right.
So am I allowed to multiply by a plus b plus c? Yes, as long as it's done to both sides.
Yeah.
Did I do it on the right-hand side? Of course, but because it's multiplied by 0, it's made my life very easy. It hasn't done anything.
Yeah.
Good. So don't just say, I only do that with 0. You can do that anytime. You can do whatever you want at any stage of your steps. All right. Good. Good question. Thank you. Anything else? Anybody else? All right. Again, creativity. Let's see if you guys can get it out. Hence, show that x plus y plus z is greater than or equal to 3 cube root x, y, z. Cube root. No, sorry. 3 cube root. 3. Let's get this 3 out of the way. Okay. Come on, someone tell me. How are we going to show this? Hence. And yeah, I'll make it even more of this.
Would you let a equals x, b equals y, something like that?
Yes. Do you want to tell me the exact one?
Yeah, that's just what I thought.
You're saying let a equal to x. Well, you're going to just get x cubed there. Plus y
Let a
cubed.
cubed equals x.
Okay, there we go. See? Now we're getting there. Let a cubed equal to x. Let b cubed equal to y. Let c cubed equal to z. Then we get x plus y plus z is greater than or equal to 3 cube root, oh, I keep doing that, 3 cube root of x, y, z, because we know that a is the cube root of x, b is the cube root of y, and c is the cube root of z. Beautiful. How easy was that? See?
Super easy.
You've got to keep your eye out for this stuff. Good job. And that just comes back to what we've done before with the letting x and y equal to each other, whatever. These ones here. We said let x squared equal to this. You're allowed to do that. When you see it's fairly similar, like, oh yeah, let me just let it equal to this thing. That is the technique, though. You're meant to use it anyways. Any questions? All right. The inequality is true with equality when x equals to y. Use the inequality to show the minimum value of the function. All right, we haven't done calculus cases, so I don't really want to do these ones. Combinations of inequalities. Yeah, again, these will be part of increasing, so part of functions. Calculus. All right. How are we going for time? Oh. All right, next week we'll start calculus inequalities. So part of, yeah, geometry and calculus inequalities. Okay, calculus inequalities next week. And then we've got all this stuff to do. It's going to be a lot. Proofs will probably take us, from what I can see right now, will take us the whole term. For me to cover it and for us to say, yes, I can do this. So we'll probably be on this topic for a full term. And hopefully by then you would have mastered all of these basic cases. And the good news is they don't really change beyond this. So what we'll do, since I've got a little bit of time, I'll stop this.